So IA-244 here at Eastern Michigan is a Windows class per se, Microsoft Windows. But technically this is system administration. And at the heart of every system admin's daily tasks are dealing with servers of all kinds. Network servers, web servers, mail servers, all kinds of that. And when I say all kinds, all kinds of flavors. Everything from Linux to Unix to Windows to Red Hat and everything in between. So what this week is going to be, and hopefully the majority of this semester, is an agnostic look at the heart of what every server actually is, meaning the kernel. At least this week we're going to be exploring the kernel. Now the Microsoft kernel, not the operating system itself. Of course the kernel is the heart, the nucleus of the operating system, but the Microsoft kernel was actually based on something called the CP/M, or the product was actually called Control for Microcomputers. Now that was, I'm going to say, a unique and objective and kind of like a central repository for products such as the Osborne 1 and the K-Pro 2 and the original IBM PCs. Now these were all brands from the 70s. Microsoft then borrowed concepts of its networking structure for their Windows NT inspired products from Unix, of all places. Speaking of Unix, before there was such a thing as Unix, there was what they called mainframe, IBM's mainframe. And that kind of goes all the way back to the 60s and 70s, of all places, when educators, mathematicians, scientists, and architects and the like all had to borrow time, meaning they had to take turns to use a so-called dumb terminal, which would have wires that connected to the mainframe, which was actually a time sharing device. Everyone had an opportunity to compute on this mainframe. Now the mainframe was only there to do calculations that the human being couldn't do, and you have to keep in mind this is before actually calculators. You could, when I was born in 71, so I remember when I was about 11 or 12, I got my first calculator, and I remember it was very expensive. It was probably $200 for a calculator, an actual calculator, not a computer. Not like nowadays you can get like a Chromebook or something for like $150. You could get a Raspberry Pi for a couple $100. No, I'm talking about an actual calculator that was maybe the size of your hand, and all I could do was add addition, subtraction, division, multiplication. If you were lucky, it would have the memory function. It might have the square root function, but that's about it. And that was the importance of a mainframe, because you could do those important calculations. Imagine calculations for space exploration, calculations for computing, I'm going to say airline flights. Back then, movie theaters, airlines, all, education, hospitals, financial, they all use mainframe. Now, mainframe was used a lot in a lot of places for education too. So when I was picturing things, people like mathematicians, scientists, and architects, these would have been at like universities. Back then, you didn't have the mainframe in your house or anything. Maybe if you're lucky, if you're working for one of those big ad agencies, and back, if you've ever watched the show Mad Men, they might have had certain accesses to mainframe, but even that was rare. You had to go to a certain special place like a university to get a hold of this mainframe. So your window, to the mainframe was, imagine, a dumb terminal. All a dumb terminal was this monitor with a keyboard, and there was no processing power at all on the keyboard. Everything was literally all the zeros and ones, all the keystrokes I'm sorry, I just got a text and I was distracted for a second. All the keystrokes that were given represented zeros and ones, let's say, and it was the processing power was either directly connected to the mainframe, or all the calculations you did were done on punch cards, and you actually brought the punch cards to the mainframe and you fed the punch card into the mainframe, and the mainframe would spit out some sort of an answer for you. It was a mainframe essentially was the world's biggest calculator because nobody had calculators back then. Then there were companies like Sinclair that made personal computers slightly more powerful than the dumb terminals, and so in other words, you actually had local computing power a little bit, and not very much. But then Ken Thompson, in all his brilliance, came out with something called Unix. Unix was more powerful than the mainframe, so you actually had a personal computer that you could actually consider a workstation. Now you can finally do things like 3D graphics, and you can actually run actual applications that you might consider like maybe kind of like something like organizing files and things like that that you could do with your computer today. But the main thing that Unix had that was in common with the mainframe was that you could use made for multi-users, and so you could have people log in or work on it, and you could use time-sharing algorithms so that more than one person could utilize one machine. So Unix was kind of like the popularized. It kind of made mainframe accessible to universities and all that who didn't have the budget for mainframe. Okay. However, the other thing that Unix created a cultural shift, kind of like the Beatles did for rock and roll. So Unix facilitated, and basically, when I say this, I'm going to use this phrase, they facilitated correlated advances. Okay? See, Ken Thompson, as I mentioned before, was the absolute genius who nearly single-handedly wrote the original proof of concept, or POC, of Unix, but it was written in a language called B. It was his companion Dennis Ritchie that wrote C and totally helped him improve the original, I'm going to say iteration of Unix. And this Dennis Ritchie, because he created C to write the next invention or the next iteration of Unix, by doing that, they exploded the capabilities, maintainability or portability of Unix, but he also C inspired other languages like C++, Java, Python, C#, Go, Ruby, Rust, everything. Every language you pretty much see today all have lineage traced directly to Dennis Ritchie, and all of that thanks to Unix, which necessitated the writing of C. If you place Dennis Ritchie, Ken Thompson, and maybe the originator of the Ethernet, if you put them all in one room, maybe you could have the world's largest geek squad. And the person that, I'm going to look it up right now. I've been trying to think of this all day. Ethernet creator. And he's on the top. Robert Metcalfe. So if you put Robert Metcalfe, Dennis Ritchie, and Ken Thompson in the same room, you'd have the world's first geek squad, believe it or not. And this is all happening in the 60s, 70s. Of course, the Ethernet, Robert Metcalfe created the Ethernet in the early 80s. He based it off of the Aloha Net, which is, believe it or not, a shortwave radio system. And he said to himself, hey, if they can share, information, if they can transmit in basically, a small area, of distance with radio waves, which is what the Aloha Net was, he said, we can transmit information from PC to PC with simple like steel cable, and he created the world's first Ethernet. But that being said, Dennis Ritchie, Ken Thompson, and it's been a long day, even though I had today was my day off, Robert Metcalf. So you got Robert Metcalf, Ken Thompson, and Dennis Ritchie. That would make a hell of a geek squad. But anyways, back to Unix and Microsoft and all that, that fun area. Believe it or not, have you ever heard of Xenix? Xenix was Microsoft's answer to Unix, because it was kind of like a joint venture. And then the Xenix project was actually sold to IBM and inspired their OS2 offerings, if you've ever heard of products like DB2 and whatnot. And Microsoft began their quote-unquote race to the NT kernel, because and I'll give you a good shortcut in the right up above here, because they wanted to integrate networking, meaning multi-user, into their kernel. Hence Windows NT, which came out in 1993 and thus was the basis for all Windows Server kernels until Windows Server 2000. So a little history lesson to put what I'm about to talk about into context.